In this video, let's take a look at what are deep neural networks. Let's first recap what is a perceptron, then let's take a look at a single layer neural network, then we will take a look at a deep neural network. Alright, now the first thing is the perceptron. So we've already seen what a perceptron is, so let's quickly recap on the different stages. So the first stage is the input, where we get the input. The next is the weights. The next stage is the weighted sum. Then you have the bias. Then you have the activation function, and then finally you have the output. If you take a look at this structure, the neuron of this specific structure will be the combination of weighted sum, bias, and activation function. So this is what constitutes as a neuron. All right. Now let's take a look at the single layer neural network. Now what we see here is we see the inputs, so the input stage remains, and we see the output, so the output stage remains as well. Each of these single dot is a neuron. So each of these dots have the weighted sum, have the bias, and the activation function. So if I go back real quick, each of the neurons or each of the gray dots in the next single layer stage has all these three components. All right. Now that's what makes a single layer neural network. So we have three neurons here. So basically three perceptrons in one single neural network. All right. In order to understand how this really works, let's take a really simple example. Let's say that you feed this neural network an image as an input. On the output side, you want the image to be classified as a letter or a number. If it is a letter, then you want the first output to fire. If it is a number, you want the second output to fire. It's pretty straightforward. All right. So in this example, let's say that this is a trained neural network, so it knows what it is doing. So you have fed this an image. The neuron 1 fires, the neuron 2 fires, and this makes the first output fire. So that means that this is a letter. In this example, you feed it an image, but this time the neuron number 2 fires, the neuron number 3 fires, and then this makes the second output fire, so that makes it a number. So it does not mean that if first and the second neuron fires, then this will make the first output fire, and if the second and the third neuron fire, this will make the second output fire. It doesn't work like that. So in the next example, we see that the first neuron fires and the third neuron fires, but it still makes the second output fire. So this is a number. So once the model is trained, the behavior is not really traceable. Maybe with one layer you can really trace it to the point where you can put a finger on it, but as the layers increase, it becomes increasingly complex and very hard to trace as to why a certain neuron fired. Now that we understand what is a perceptron, we understand what is a single layer neural network. Now let's take a look at a deep neural network. So everything remains the same. So you have the input, you have the output stage, and the only difference here is you have two hidden layers. So this is one way of categorizing a deep neural network, which is to say that if a multi-layer neural network has more than two hidden layers, then this can be called as a deep neural network. Now, since we have two hidden layers, now this goes through a more fine-grained decision process within itself, and along with it also becomes complicated to trace. In the next video, we'll take a look at feed-forward neural network, and we'll also take an example as to how it trains itself.